Hello, scrappers and scavengers. My name is Clint Hoagland, and this is Creating Electronic Music with ChucK. In our last video, we looked at one way to create a completed song in ChucK. Specifically, we remade the Super Mario Bros. Ground theme. One thing that came up while making that composition was that I mentioned that there was an architectural concern that was bothering me that I didn't get around to solving. Well, it just so happens that in November of 2023, ChucK 1.5.2 came out, and that has a new language feature that I think is going to help solve my problem. Let's talk about constructors. ChucK 1.5.2 adds constructors to the language. A constructor is a special kind of method that is particular to class definitions. Constructors are used to do some kind of work when a new instance of a class is created. They get called when you create a new object of that type. For example, if we were to create a sine-osc variable called osc1, behind the scenes a constructor is called that sets up that oscillator instance. In most cases, we don't need to know what constructors are doing. We can just trust that the type is set up such that when you make an instance of that type, it will just work. However, ChucK also added the concept of alternate constructors, or quote-unquote constructor overloads, which will in a lot of situations make our ChucK scripts shorter and easier to read. Let's use sine-osc as an example. If we want to set up a sine oscillator and then set its frequency and then advance time, this is how we do it. We've done this dozens of times at this point. We set up the oscillator in the line where we hook it up to the DAC, then we set the frequency in another line, then finally we send some time to now. As of 1.5.2, the sine oscillator now has an alternate constructor that lets you create the oscillator with the frequency. It works like this. When you declare the oscillator instance, you can add an argument to the instance itself, like so. We can delete the line of code where we set the frequency later and it still works the same. So that means we can eliminate a certain amount of code which makes our script look cleaner. Another thing that we always seem to need is to set the gain, so let's add a gain ugen, and in another line we can set the gain's gain value to 0.25. Now it just so happens that gain ugens also have an alternate constructor, and in this case you can use it to set the gain value like so. So what was previously this turns into this, which is nicer and more concise. Now, a thing you might reasonably be asking about now is this. How are you supposed to know that these alternate constructors exist or what they do? In ChucK 1.4.1, they added built-in help for objects in ChucK. Any object's documentation can be accessed by launching the object's .help parenthesis property. Accessing this causes the object's type documentation to print to the console. Let's try it out with a sine oscillator. We create an instance of the sine-osc type, let's call it osc1, and then we call osc1's .help parentheses property. Now let's run the script and look at the console output. It printed out a huge amount of useful information onto our console. First, there's a text description, and then it shows the object's inheritance tree. If you need a refresher on object hierarchies and inheritance, video number 23 explains how that works. After that is a list of constructors, which is exactly what we are looking for. There's a default constructor, which is the one we usually use, and also there are two more. One that lets you specify the frequency of the sine oscillator, and one that lets you specify both the frequency and the phase. When we put a single value into our oscillator's constructor, that meant we chose the constructor that has one argument, which in this case is the one that chooses the frequency. After the constructors, we have documentation for all the functions that a sine-osc can use, all in one convenient place. It organizes them by where it gets the function from, so you can see here that the majority of functions that are available in sine-osc come from the osc type, which is what the sine-osc inherits from. But some of the other things that we use, like gain for example, actually come from ugen. Let's do the same thing for the sound buff ugen. As we can see, it also printed a lot of info onto the console. Helpfully, we can see that there's an alternate constructor that takes a file path. Helpful. Once again, there's comprehensive documentation of all the functions available in the sound buff ugen. Feel free to peruse them at your leisure and try this with other ugens. Okay, we can see that constructors are useful at making our code more concise, and we have seen how to discover them by using objects' help properties. What are some things we can do by making constructors in our own code? Here's a simple class I made to remind myself how ChucK graphs work. For more information, check out video number 24, which I made back when ChucK graphs were still called ChucK graphs. This class just extends ChucK graph, and it hooks a saw oscillator into a low-pass filter, which then goes into a gain ugen into the DAC. Down here I use it. It sounds like this. Okay, let's try making a constructor. To make a constructor, we type fun at construct with parentheses. If there are no arguments, then we're defining what happens in the default constructor. The LPF ugen doesn't have a constructor that sets its frequency at the moment, so let's set that in the constructor as well. Now if we call that in the script, we can hear how it sounds different. We changed the frequency in this constructor. Now, using a constructor in this fashion doesn't really buy us anything. We were always able to set all this up without one. It gets more interesting when we start adding arguments to alternate constructors. To make another constructor, just make another method called fun@construct, but this time we'll add an argument to it. I've added a float argument called askFreq, and I used it down here so that when we call this constructor, we set the frequency of the sine oscillator. So now it's suddenly super easy to make more of these oscillators with other frequencies. Let's add a constructor with a couple more arguments. Let's add arguments for the filter frequency and resonance. Pretty simple to do, but you might have noticed that these are starting not to look so simple. What do these numbers represent? Well, we can call .help parentheses on our own object and it will still log the documentation to the console, including the constructors. So if we did a good job of naming the arguments, then we can see how these constructors are supposed to be used. This will be particularly helpful if you're trying to build up libraries of helpful objects that you bring together in some kind of more complicated score. Lastly, one more cool thing we can do is we can pass objects into other objects. I added a constructor that takes a frequency and an osc type, which is the type that sine osc and saw osc and others inherit from. That allows us to pass in different oscillators that inherit from that type. Here I've got it passing in 2 sine oscillators. We don't actually use the names of these objects anywhere, so if we don't want to name them, we can use the new keyword like this. The new keyword creates an object of that type that doesn't have a name, which is fine for this usage. Now we can switch out any type that inherits from the osc type. Let's try it with a saw oscillator and a square oscillator. So now, by using a couple of constructors, we created a really convenient test bed to experiment with different combinations of oscillator types. In this video, we looked at constructors and how they can make our code more concise and powerful. We also looked at how to access objects help documentation. In the next video, I'm hoping to look at unit analyzers.